Good evening all. Today's our subject is FDCS and its installation process. You all know our loco was having a fleet of nearly 190 conventional locos. At that time, majority of the locos were relay fitted locos, and later on many locos came with FDCS fitted by either production unit or during POH by POH shops. FDCS is fault diagnosis and control system. In other words, you can call it as MPCS, that is microprocessor based fault diagnosis and control system. Earlier, all the locos were fitted with relays, that is, many relays were there, Q50, 51, QV60, QV61, QV62, QV63, QV64, like that. Many relays were there. For each and every control circuit, one relay or another relay was fitted, and the relay function was ensuring the loco working. If you see one relay, that is Q50, Q50 is important for traction purposes. In that Q50, there were nearly some 50 or 60 interlocks in that circuit. That is, each CTF, each reverser, each SWC, each and everything was having an interlock in that circuit for Q50. So, in case of any malfunctioning of any one interlock, that was causing a loco failure. That much redundant relay units were there earlier. To reduce the number of relay interlocks and to simplify the circuit, later on this FDCS concept was came, and new locos were fitted with FDCS. We can go, this is the FDCS main unit, and this is maintained by E4 section. This is the display unit. Microprocessor based fault diagnosis and control system, that is a MPCS or FDCS. Okay, the passenger electric locomotives use electromechanical relays or contactors for control. Such control involves large number of interlocks, contacts, interconnections, and cabling, which are not only maintenance intensive but are unreliable too. This control is intended to primarily replace some of the existing conventional relays, reduce cabling, and provide additional fault diagnosis information by providing software based control logic. This is the block diagram. I am not going in depth because you all are aware about that. Anyhow, only introduction about the units. This is ISCU or Intelligent Signal Conditioning Unit. ISCU, two numbers are there. One for TM123 fitted in BA1 panel, and another unit for TM456 fitted in BA2 panel. This is the main unit, and another is Signal Conditioning Unit, and there is an antenna fitted with GSM, and it provides the GPS location also. Both cabs 10.4 inch LCD TFT monitors are there. In version 3, 10.4 inch monitors are there, and in version 2 there is a small display unit only. Other than that, one notch encoder is fitted in the SMGR unit to count the notches in the SMGR. In the main unit, there are digital input cards, digital output cards, analog input card, control cards, vigilance unit, energy metering, speed recorder, and LRMS for remote monitoring system. This is signal conditioning unit. SCU is used to measure the different analog values like auxiliary voltage, brake pipe and brake cylinder pressure, OHC current, OHC current through current transformer, Arno or static inverter output phase voltage, battery voltage, TM voltage, and loco speed. ISCU is used to measure the traction motor current. For TM123 there is one unit, and TM456 there is another unit. ISCU 1 and 2 communicates with the main unit through independent RS485 communication channels. This is the TM current sensor. Traction motor current sensor is of non-contact type and works on the principle of Hall effect. These sensors measure DC traction motor current flowing through the conductor which is passing through them in a non-contact way. It is a bayonet connector for connecting into ISCU. One simple circuit we are checking. This is a VPT1 magnetol pickup circuit. What is there? One interlock is there. for QEMS, ZPT switch is there, and VPT magnetron is there. This is the logic, simple how the logic works. That is, once ZPT interlock is there, VPT is closed, and in the BPEMS or QEMS relay is de-energized condition or BPEMS is not pressed, then BPT1 coil will get energized. This is the simple circuit. Most of the people are young and you people are aware about that logic circuit, that is gate logic, Boolean algebra, you people are aware now. So it is very simple if you know that. This NOT gate, OR gate, AND gate are used for FDCS. I am not going in depth. This is the Q44 relay and the VCB closing circuit in a conventional loco. This is the Q44 relay interlock. For that, all these interlocks, this one, all these conditions should be satisfied. For that, what we did is FDCS. There is no physical Q44, whereas it is done in the processor unit. For that, whatever inputs are required, that is given as input to the FDCS unit card, and its output is given to corresponding circuit, and for VCB closing, there is no physical relay provided. This is the logic. AND gate is there, OR gate is there, and you can simply calculate if we give logical 1 here or logical 0 here, the corresponding output of Q44 will be high, and there is a delay timer for 0.6 seconds. These and all are inputs for FDCS cards. Input card 1 is having I0 to I31. Like that, cards are there, different inputs are there. And to select the loco type as WAT4 or WAG7 or WAG5 or even WAM4, that loco is not there now. Or whether it is Arno loco or static inverter fitted loco, whether it is having a vertical DBR or roof mounted DBR, these corresponding inputs are given 0 or 1, logical 0 or logical 1. For logical 1, the feed is, that input is directly connected to 110 volt DC positive. For logical 0, that input is connected to 110 volt negative side. Now we are going to the main part, that is how to convert a relay loco to FDCS. That is our main subject. Till now we are going through what is FDCS. There are huge process of different cabling activities for converting from relay to FDCS. The first thing is we have to plan the material. For a loco, nearly 350 meters of 19 core cable is required, and more than 70 meters of neoprene rubber sheet, and 1500 numbers of cable lugs, cable numbering ferrules, heat sinkable sleeves, and skilled manpower required for converting a relay loco to FDCS. First thing is we have to plan what are the cables to be provided. In that, we have to create the list of cables required for each and every location. For that, firstly, we are going to cab 1. Cab 1, for BL box, what are the cables required? Firstly, we have to find out. For BL box, BLDJ is there, BLRDJ is there, BLCP, BLVMT, BLSN, heater, BLRA, and other switches are there. I am not going one by one switches. So what are the switches inputs required? Like that we have to find, and based on that the cable leg should be 4.2 square mm cable leg, and from BL box to cab SB we have to provide nearly 45 cables, including some 3 or 4 for future modification, 3 or 4 spare we are providing, and BL interlock everything we are providing from BL box to cab 1 SB. Like that, other location is meters. What are the meters? For TM1 U1 is there, for TM2 U2 is there, for TM3 A3 ammeter is there, and other than that for OH voltage there is a UA meter in cab 1. From all these meters, the cable insulation should be 1.5 kV in those cases, because for TM voltage the voltage may come above 750, so the cable insulation should be 1.5 kV for TM circuit cables, that is for the meter cables. Other than that, 2 cables are required for 110 volt indication lamps inside the meter. That is controlled by BLLF switch. So two cables should be provided from the meter panel to cab SB. Like that, another location is LED indication panel. LSDJ, LSAHB, LSB, LSRSI, LSOL, like that. 1 minute, sir. RDSO code. RDSO. No problem. Slide. LSDJ, LSCHB, LSB, LSRSI, LSOL, like that, all the indication lamps are there. LSDBR, everything is there, no? For all the indication lamps, one positive and a common negative is there. That is wire number 170, A170, A171, A172, A173, A174, like that for QCT A178. All this wire should be there and one common negative. That should be also laid to the cab SB. Next is buses. There are many buses, that is QTD zone buzzer is there, AFL buzzer is there. Other than that, we are providing TMDDS buzzer and HSM buzzer, and many other modification buzzers are coming. So some 6 buzzers are there. Therefore, all those buzzers, separate cables are required from the buzzer fitted area to cab SB. Like that, indication lamp to, there are LSIP and other modifications there. From those lamps to cab SB, separate cabling is there. And for cab 1, 968 and 984, that is 110 volt AC supply is there. 110 volt AC supply should not mingle with other DC supply. Like that, 2 cables are required for cab 1 to cab SB. And other than that, switches are there. Many switches are there. The switches also need separate wiring. Flasher unit will be relocated because that cab display unit we have to fit in the location where flasher was earlier fitted. Flasher control unit was earlier fitted. So new cables are required for flasher unit, that is 801, 802 and 003 and B minus. 4 cables are required for, one more is required for flasher, this one auto flasher. All the 5 cables required from flasher control unit to cab SB. And from cab SB to the flasher main unit and for headlight we can do renumbering because the old cable we can use. Like that, cab lights are there. Both in the cab CFL and group lamp LSGRPT lamp is there, and driver reading light is there, LP reading light is there. From all these lights, positive and negative will come. All these should be terminated in the cab SB. The first thing what we have to do is cable preparation and numbering. Separately we have to prepare the cable numbers what are required from where to where and make it as a list and plan the cutting length and do a proper cutting with one end crimping and numbering. The second thing is crimping and numbering. That is, the cable should be crimped based on the requirement of the cable lug in the end connection. There are certain locations having M6 head. That is, for meters the cable leg should be the connection nut size is 5.2 mm. So we have to use M6 cable leg with a 3 square mm. Whereas for BL box et al. Auxiliary interlocks, it should be 4.2 whole dia. So based on the requirement, different locations should be having different size cable legs. The third thing is cable bunching. All should ensure that there is no sharp edge which is directly hitting on the cable. To prevent that, if there is a sharp edge, any angle or any metal sharp edge terminal is there, provide a proper cable stiffener welded at both ends and provide tape on that stiffener. Apply varnish one layer so that it will get stiff and it will withstand long life, and then bunch the cable in that stiffener and provide proper ties. Always use CLW approved cable ties only. Don't purchase any local market cable ties and don't use it because loco is fire prone. So we have to ensure that properly tested and proper quality material is used for cabling. All the cables used should be as per CLW specification, that is as per RDSO specification, that is RDSO spec number ELR spec 0019 revision 4 is there. That spec cable only should be used, and based on the working voltage of the circuit you have to select the cable. That is the important thing. That is control circuit. Whatever 110 volt control circuit is there, you can use 750 volt normal cables as per the specification. Wherever power circuit or high voltage is coming, use 1.5 kV cables only. Don't use 750 volt cable, because during short run itself that cable will fail due to insulation failure, and that will cause a loco failure. Now we have discussed about the cabling in the cabin. There are many cables coming from different equipments to the cab SB panel. From cab SB panel to the BD panel, it is always better to provide 19 core cables. 24 meter is the cable length required from the cab SB panel to the BD panel. All the cables from cab SB panel to BD should be provided in one cable trench, preferably cable trench 2, that is SMGR side, because many AC circuits are coming in the cable trench 1, which is near the HOM side. In the HOM provided side is having AC power supply, that is from transformer bushing to SIV, and SIV output to MVSI and many other MV, MCP and all coming through that route. So if we provide control cable along with the auxiliary 750 volt or 415 volt circuit, the problem is that will cause an induced voltage in the control circuit, and that will cause unwanted logical high for an FDCS input. Even if we are not switching on BLCP, during a train working, when it is a full load, at that time, even if we are not switching on BLCP, this stray voltage induced due to the 415 volt AC, that will cause a digital high to the FDCS, because FDCS is always using digital high and digital low only, logical input only. So 110 volt, there is no current in that, milli or microamps only current is there. So this stray voltage itself will cause a malfunction. The main malfunction we can observe in this locus is pilot lamps glowing dim. That is, pilot lamps are LED type only, that needs some 20 or 30 volt only for glowing dim. So during train working, during night time, that is a very difficult thing for the loco pilot, that all this pilot lamp will glow dim, and he can't concentrate in the track because it is glowing dim. Oh, that circuit is malfunctioning, so that lamp is glowing. Like that, he will get some confusion frequently because of the dim light. To prevent that, during cabling time itself, I should ensure that all the control cables are laid in one bench, and in that AC cables are not there. What are the cables connected to cab 1 in AC circuit? That is for UA meter, 991 and 993 wires from BD panel to cab 1 for UA meter. That is voltmeter, Arno voltmeter, or for indicating a OH voltage. Other than that, 965 and 222 for heater circuit. Other than that, cab fan, it is the 968 and 984 for cab fan. And for speedometer, 991 and 993 bar 1 for speedometer, that signaling unit is there in the cab 1 side wall. For that, the cable length is required throughout the trench from the BD panel. All these cables should be bunched. That is, all these AC cables should be bunched separately, and all the DC cables should be bunched separately, and ensure that there is a 5 to 10 mm air gap or separation between these two. This will ensure that there is no EMI in the other EMI caused in the control circuit. Now we have discussed the cabling for cab 1. For cab 2, there is a slight variation, that is 1 or 2 inputs only changed, and some cable number only changes. That is, in BLSN 2 cables are changing, and total of some 10 cable number only changing, almost similar only for cab 2. For BA1 panel, what are the inputs? L1, L2, L3 coil inputs are there, and shunting contactor, S11 to S33, 1, 2, 3 step are, because it is WHSN, 1, 2, 3, 3 steps are there. For its positive cables are required, and for common negative is required. The important thing for the negative circuit is, for BA panel, for cabs, provide 2 numbers of 3 square mm cables, that is for paralleling, because due to heavy load in the control circuit, whatever positive is there, the return current through negative is going through single cable, that will cause overloading, and there are high chances of open circuit of negative cable. So provide 2 cables for the cab 1, for cab 2, for BA1 panel, and for BA2 panel, and for BA3 panel, 2 cables for negative circuit. That is, 2 negative cables are paralleled. For example, B minus 312 and B minus 313 will be the number for one cab. B minus 314 and B minus 315 will be the number for other cab. Like that, two numbers are parallel only for reliability, that is to share the load. For BA panel, line contactor input is there, reverser, CTF inputs are there, and shunting contactor inputs are there. For that, positive and negative cables. Along with that, for FDCS input, reverser throwing input, wire number 100, 99, 98 like that cables are there. 102, 102, 103 like that cables are there. That cables are also should be planned from BD panel to BA1 panel. Next comes MPH, QPH, MVRH, QVRH. The MVRH, QVRH cables are MPH, MVRH cables are same only we use, whereas the control cables we have to provide separately because earlier one cable was incoming and two were outgoing. Now different numbering is there, so we have to use new cable for MVRH, for QVRH and QPH from BD panel. Next comes SMGR. For SMGR, the number of inputs are very less in FDCS. Then also 19 core is required because exact 19 numbers of cables are required. And for EVPAGR also one positive and negative is required. During cabling itself, we have to plan for the FDCS signal cables to provide. That is from FDCS main unit to cab 1 display unit, FDCS main unit to TM current sensor, FDCS main unit to notch encoder, FDCS main unit to this TFILM CT, speedometer CT. All these cables also we have to plan and provide through the trench during the first cabling time itself. For SMGR, the different inputs and outputs also provided in the same method. Next is BA2 and next is BA3. Similar to BA1, BA2 and BA3 also requires reverser, CTF, line contactor and shunting contactor cables. For BA3, there is no reverser, whereas C145 is there. For that also separate cables are required. All these cables should be planned along with the FDCS company supplying cables for its notch encoding and signal conditioning unit also. That also should be provided. There are another cable required, that is pneumatic panel. Pneumatic panel may come near the compressor, either in near the compressor or near the captive side. Most of the locos we are having pneumatic panel near the compressor. So we have to provide 219 cores because 119 core will not be sufficient, and baby compressor also will come, that is MCPA also will come near the pneumatic panel. For MCPA, we have to ensure for positive wire number 013, two numbers, for negative wire number B minus, two numbers, because MCPA draws the current of 8 amps continuously. For its reliability and to reduce the voltage drop, provide two cables in the positive and two cables in the negative exclusively for MCPA. Like that, for RSI block also provide 190 core cable because 11 cables are required for RSI block, and the remaining we can use for QVSL, which is coming QVSL1, which is coming very near to RSI1 block. Similarly, for RSI2 block, 190 core is provided, and its extra cable which is having excess length can be used for MVSL2. Now I have covered almost all the cabling coming in the corridor. Remaining things, that is corridor light and all, we can connect from the corridor light SB terminal to BA panel, and we have to connect wire number 220 in the BA panel for the lights, because we need not take the full length of cable. Original circuit is coming as full length up to BD panel. We need not draw the full length cable because in BD panel the bunching will be huge. To reduce the cabling in the BD panel, we are providing short length cable up to the BA panel and providing one HP room light and two corridor lights in BA1 panel, and another HP room light and two corridor lights in the BA2 panel. Like that, we have to plan the cabling in the corridor. We have already discussed the cab 1, cab 2 and the corridor. Now we are coming to relay panel. In relay panel, there are very less number of relays compared to a relay loco. So the cabling is very simple. That is QLM, QOP1, QOP2, QRSI1, QRSI2, QSET, and QFL and QEMS only coming in relay loco. We have eliminated many relays, that is already told Q50, 51, 53, P354 all eliminated. So less number of relay only available. So total of 40 numbers of cable only required from relay panel to BD panel. Next comes EMC panel. EMC, the cabling is almost similar, whereas the auxiliary interlock reduced. That is, earlier auxiliary interlock, some 4 to 6 cables are coming in an auxiliary interlock. Now only one input and one output is there for the EMC auxiliary interlock. EMC, we have to separate the auxiliary interlock, that is C101, C102, C103. All auxiliary interlock should be having separate output to BD panel because separately mounted in the FDCS for the unloader circuit. Earlier in relay loco, all were in series for Q1 in relay picking up. Now it is simplified. So FDCS card input requires 3 separate inputs. So we have to provide separate cables for C101, 102, 103, C105, 106, 107, and we have to provide additional cabling for C108 also. All these cables, in that negative there is a ring main system provided in this also. That is, negative will come to C108 in coil, from there to 105, then to 106, then to 107, and from there it goes to C103, then to C102, from there to C101, and from C101 it is directly again connected back to BD panel. This system ensures that there is no voltage drop in the coil. Otherwise what happens is, when 2 or 3 coils are picked up at a time, the third coil will get reduced voltage only due to the voltage drop in the negative circuit due to picking up and the sudden inrush of current in the coil. To prevent that, there is a ring system used in the negative side also. Provide 700 or CCPT fuse output common supply to all the auxiliary interlocks and take separate output to FDCS, that is BD panel. Next comes switch panel. In switch panel, original cable we can use for the HBA, whereas all other switches we have to replace the cables. That is HUSL1, HUSL2, HUMT1, HUMT2, HURH, HMCS1, HMCS2, HQ51. That is another thing. The HQ51 is a new thing in the FTCS. In relay loco, that switch is not there. So we have to provide HQ51 also. Other than that, HVCD comes and HSIV comes. All these cables we have to provide from the switch panel. 64 cables from the switch panel to BD. Along with that, the fuse panel is there. In the fuse panel, we have to monitor one important thing, that is that the cable size should be 10 square mm for the CCBA and CCPT because that was more current. Other fuses we can use 3 square mm, whereas this CCBA and CCPT should be having 10 square mm cable for its current carrying capacity. All these cables should be connected to BD panel. Another thing, backside of BD panel is FDCS main unit and FDCS SCU. SCU, which is fitted backside of BD panel, that is for this OH voltage sensing through SIV input, that is 991 and 993, and SIV output voltage sensing, that is 965 and 966, and TM voltage sensing through A17 and HO2. Other than that, 700 is there for its internal working, B minus is there, and 973 is there for SIV charger pickup sensing. All these inputs are connected to signal conditioning unit fitted backside of BD panel, backside of EMC panel near the NMT2. Small cablings are there for VESA2 and VEPT2, like that. Some small air dryer, these are all very small things that can be done easily. All requires 3 square mm for this control cables. The main wiring comes in the BD panel after the completion of cap cabling. The points are cable numbering. We have to ensure proper numbering of the cable as per the cabling index provided by CLW. The cable number should be the same in both the ends. That is, wire number A170, if we are placing at one end, the A170 should be there in the other end. It should not be B180 or some other number. The cabling number is having a simple method. That is, normally the series A is connected to the end terminal equipment. And for cab 1 to BD panel, the index series will be B. and for cab 2 to BD panel it will be C. Like that it grows, that is ABCDE. In case of MU is there, that is WG7 loco, MU jumbers are provided. Normally MU jumbers will be provided with G, H and JK. G, H, I, JK, like that only it will come based on the index. Normally for MU, ABCD will not be there because it comes in the end. Whereas normally the equipment or coil connection or the main input area, it will be A at the equipment terminal side. The numbering sequence is having a method like that. Cable sleeving. All cables should be sleeved after providing proper numbering, proper crimping. All cables should be sleeved using heat sinkable sleeve of suitable size. That is, for 3 square mm cable, the sleeve used should be 5A. That is the dimension for the sleeve. Different size are there: 5A, 6A, 7A, 8A, 9A, 10A, 11A, 12A, 13A. Up to 13A it is there. Normally we need for 300 square mm we need 12A cable size only. Till now we have discussed about the control cable. Now we have to go to the power side. That is, earlier QD1 was there, QD2 was there, SHA was there, everything is eliminated and Hall effect sensors are provided wherever required. So for Hall effect sensors, input should be directly from the TM, that is H. For traction motor power circuit, armature positive side or armature starting side is numbered as A. Armature winding ending side or AA is numbered as H. And like that, field starting is numbered as E. And field ending is numbered as F. A, H, E, F is the sequence. In that, A side is connected to line contactor for TM1, 2, 3, 4, 5, 6. We are not providing the Hall effect sensor in the positive side. We are providing in the negative side where the same current is flowing. So immediately after armature or the cable from the traction motor to BA panel, H cable we are disconnecting from the BA panel and we are routing it through the Hall effect sensor. We have seen that Hall effect sensor in the third or fourth slide. Through a bus bar we are inserting the Hall effect sensor and the cable is connected to the BA panel. Like that, for all traction motors, Hall effect sensors are provided for 1, 2, 3, 4, 5, 6. All traction motor current is measured and recorded in the FDCS unit. So the connection should be in the correct way and the connector should be for TM1, it should be TM1 only. We should not connect TM2 or TM3. What will happen is, in case there is a current difference between TM1 and 3, that will cause a QD action. So we have to ensure that Hall effect sensor TM1 connection is connected to TM1 circuit only. And like that TM2 to TM2 only. We should not change the connections based on our wish. It should be as per the circuit only. Otherwise that will cause auto regression continuously. Other than that, now the SHF, that shunt for this braking RB is removed. So we have to bypass that circuit and we have to replace the cable from BA1 panel and BA2 panel to the DBR with a new cable. The cable size should be 150 square mm for the DBR cable, 4 numbers, and for power circuit, the input should be 240 square mm for the Hall effect sensor. That is the power side. Another thing for cabling is this I have to tell firstly, that is SB preparation. Firstly, we have to prepare the SB terminals based on our requirement. We have to make the list of cables which are coming in that circuit, in that cab. Based on that order, we have to prepare the SB, and in that SB there is a copper link plate. Tinned copper link plate is there. In that plate, we have to punch the wire number. That is wire number 003 means we have to punch the wire number using 6 mm punch in the each SB and connect the SB terminal. The SB preparation, we have to ensure that sufficient spare SBs are provided for future development also, and SB should be separated for auxiliary or power circuit. The thing is, for heater circuit, that is 415 volt circuit is there, or for this one meter circuit, voltmeter circuit, high voltage, that is 700 or 800 volt is coming. In such cases, ensure that after one connection, one free SB or bare SB is provided without any connection, so that the voltage gradient is protected. And ensure that neoprene rubber sheet is provided backside of the SB to prevent any insulation failure in the future. See, this is the method. Cable number is punched. No, this is 034, this is 055, 065, 066, 067, 068, like that cable number is there. Connected on the both ends, and wherever required, one SB spare is also provided. See, one SB is kept as spare only. One SB is kept as spare only. Here also one kept as spare only. Normally in cab there are 4 lines: SB1, SB2, SB3, SB4, like that. 4 is there, means each bar we can provide up to 32 numbers. We have to prepare a circuit maximum 26 or 27, so that in case of any additional SBs required, we can use the pair in between. Other than that, in the last row we are keeping some 10 to 12 as pair for future modification of circuits. This is the BD panel. In the BD panel you can see 003 junction is there. All the 003 are connected together. In that, one more thing is there. 003, 2 10 square ohm are provided nearby. That means one is from battery and another is from the charger. If we are providing 1003 here from battery and another one here, when the charger is working, the current flows through all these SP terminal up to this point. What happens is, in case of any loose connection in between this SB, that will cause overheating and open circuit. To prevent that, we are providing 2 high current junctions in the nearby point, so that the current will flow in that point only. This is the BD panel connection. Many inputs are connected from the BD panel to the FDCS main unit. Normally that is done by the commissioning section, that is the firm only, because commissioning of the FDCS is also the part of the supply, so they will come and connect from the BD panel to their unit. We have to support them by showing which connection comes to which point, like that. We have to support them, and we have to ensure that the input and output they have connected is correct only and as per the circuit only, like that we have to ensure. You can see O37 is there, I33 is there, I34 is there, like that many inputs are there and many outputs are there. One more thing to check is, provide additional rubber sheet in the corners wherever there are possibility of rubbing is there, because these locos work at a speed of 100 kmph. There will be very high vibration. There are high chances of insulation failure due to rubbing. To prevent that, provide additional rubber sheet in the corners. I think I covered most of the points in the commissioning, and the one thing is the first loco which was converted from relay to FDCS is at Erode only, that is 22603. Firstly, that loco was fitted with relay only. It was having frequent failures due to many cable rubbing and all. That loco was transferred from other shed to Erode. At that time many failures were there, so we stopped that loco for conversion, and within 1 month we have successfully converted the loco from relay to FDCS. After that, we have done 29 locos conversion from relay to FDCS, and as on date we have completed 30 locos FDCS conversion in this shed itself, and out of the 94 WG7 locos, 65 are fitted with FDCS. And in our earlier holding, that is many WP4 transferred. Earlier we had 127 WP4. At that time, the relay loco holding was nearly 70 and remaining was FDCS. Now also we are having a very good population of the FDCS. The FDCS provision is giving a very good relief to the loco pilot, because they need not search for any fault in case of loco tripping. Otherwise, he has to run from this cab to that cab, and he has to check this, that, like that. In case of FDCS, everything is displayed on the screen. Based on the display instruction, he can bypass or he can isolate the equipment, and he can work the train without punctuality loss or timing loss. So FDCS is a very good thing. One more thing, the main benefit for us is we can identify the location because all the locals are fitted with the GPS, and we can log into the site, that is locomon.in. That is the website for that, locomon.in, and we have to use the username and password, and we can log in. We can check the online location, health condition, whether loco is working satisfactorily or any problem is there, what are the fault logged in that, and we can download the fault data also in Excel file. We can analyze and what happened at that time, at the incident time, and what was the speed of the train at that time, what was the switch position, what LP was doing, anything, any loco side trouble is there or any other trouble is there, everything we can analyze city here itself. So the FDCS is having a very good use in our train working, and our LPs also having very good use because of they can identify the fault in the display itself. Remaining some 29 locos are there that Shed is planning to convert. So in future all will be fitted with FDCS. Thank you.